Hi everyone, welcome to my channel once again. In this video, I'm going to explore the OpenAI API for SQL generation. My goal is to generate basic SQL queries, and also at the end, I will test if it can solve complex SQL problem or not. I have already tested a lot of prompt so that I don't have to figure out everything from the scratch in this video. Let's start. So first, let's check out the site where we can see the API details. These are different examples of OpenAI API. And for my video, I'm going to work on the SQL Translate, where I'm going to use the OpenAI API to translate plain English language to SQL queries. So this is an example of how we can use the API to generate the SQL query. And ideally for this SQL query, this is the prompt we have to give. And there are a bunch of settings we have to do when we are calling the API. We can cover the settings once we start writing the program in Jupyter. Let's go to the Jupyter notebook and start writing the program. So in this program, my goal is to first generate the SQL query using the API and then use the query to run it on the Postgres SQL. So I already have the Postgres SQL installed in my local. I'm going to generate the query using the API and then going to run that query in the Postgres SQL database. All right, so I have, before I do anything, I have to import bunch of packages. The scicop g2 is needed to connect to the Postgres SQL database. Import OS is just to interact with the local operating system, and OpenAI module is needed to call the API. And before anyone tries this, they have to first install the OpenAI package in local. In my system, the way I install the packages, like I just run the pip install OpenAI. Let me show how we can do this from the shell, and we can also do this from Jupyter Notebook itself. So I can give one example. So when I have to install the package from the notebook itself, I use this syntax. So this syntax is like a kind of not equal to, but in this context, it tells the Jupyter that it has to run this command in the shell. And let's run this. So now this is going to install the OpenAI, but I already have the API, so that's why it's saying that requirement already satisfied. Let's delete this cell. Okay, another thing needed in order to call the OpenAI API is the OpenAPI key. And I have already generated the API key in my OpenAI account, and I have stored that API key in the Jupyter variable. So I'm just going to import the key here, and I'm going to use it in the API. I'm also going to establish the connection with my Postgres SQL database. So these are the default values when you set up the Postgres SQL in your local. Okay, so another thing I want to do is instead of calling the API every time with all the parameters, I'm going to declare the API in a function, so that I'll just call the function. I don't have to declare the parameter every time. The only thing I'll be changing in the API parameter is the prompt. Let's write that function. Let's copy the syntax from here. And at the end, we are going to return the response. Response is nothing but the SQL query. Let's also get the key. Okay, now let's change some of the parameter. So when this function will be called, we'll be passing the query, basically the prompt. So we are going to use that as a prompt, and let's change this to query prompt, so that way it will be more meaningful. Okay, now let's talk about these different parameters. So in this function, the model is the engine or the model what this API is using in order to generate the SQL. Prompt is just a regular or plain English. We are going to send it to the API. Temperature is a measurement of randomness or creativity for the generated text. So basically, if the temperature is more, it will generate the diverse text, and if it is less, it will be slightly narrower. Max token is the number of words, whatever text we are going to get back from the API, the number of words in that text depend on the max token. So when we know that my prompt is going to generate a bigger query, so in that scenario we have to increase the max token. Top p is basically a parameter which makes the text and story more interesting. So what that means is like it won't pick up the word again and again. For SQL generation, top P is basically 1. And also, based on my research, if we are trying to generate more complicated queries, then we have to increase the top P, like make it to 2 or 3. And there are these two penalty parameters. So these parameters are to encourage or discourage the model from generating certain words or phrases based on their frequency in the text. The stop parameter is basically it's a list of strings. When the model encounters these characters, it should stop generating the text. That's pretty much about different variables which are being used as part of the API call. Now let's write down bunch of prompt and try to generate queries. My first prompt would be to create a table, and I have the prompts written in a different document. I'm just going to copy and paste it here. So in this prompt, what I'm saying is write a SQL query to create customer order table with following columns: customer ID, name, email, order ID, order date, order status, state, and country. So when we give the prompt to the model or engine, we have to be very specific what we are trying to do. In the first few words, we are saying the engine that write a SQL query, and then we are also giving the table name, and then we are also giving all the columns which we want in the table. Let's call the function. Let's run it. Okay, so it ran successfully without any error. Check out the response. Okay, so this is the entire response from the API, and in the text part it has the query. Let's try to print it in a more readable format. So this is more readable, and it has given the syntax for creating the table customer order, and based on the best practices it's also suggesting to keep certain columns null, not null, and it's also suggesting to create the primary key based on two keys, customer ID and the order ID, which looks good. Next thing what I want to do is to run this query directly into the database, and let's see if it works or not. I'm going to create a new cell, and I'm going to create a cursor for connection, and probably I'll do that in the top section. I have to create the cursor just once, and then I'll keep on executing using that cursor. So CUR this. Okay, so and I'm going to use that cursor here, execute, and Let's save this in another variable, final query, and I'm going to run this one into the cursor. Now I'll also create another execute statement, because it's a good practice to commit the transaction every time we are running any query in the database, especially in the case of PostgreSQL where you have to commit explicitly. Commit. Okay, so let's run it, see if it is working or not. Okay, seems like it worked. The most easy way to check if this has worked or not, if we run this again, it will fail. Let's do that. Yep, now it's saying that the relation customer order already exists. I'll just go ahead and remove this error. Let's look into the database and see if this table is there or not. So this is the list of table. Okay, so customer order is there, but there's no data in the customer order table. Okay, let's go back to the script. Okay, so I'm moving to the next step where I am trying to generate the insert SQL for 10 sample records. So let's just copy the same old stuff and we will change the prompt. So let's modify the prompt here. Write a SQL query to insert 10 sample records in the customer order table with following columns. And I'm going to give all this column, and I also want the insert query to follow the data type of individual columns. So my plan is to also feed the data type in the prompt, and I'll just copy paste the entire thing, and I'll remove the not null clause from everywhere. Because that will help the engine to generate the correct value. It should not generate integer instead of string or string instead of integer. That will fail my insert script. So I don't care too much about the null and not null unless the engine does not give me the value for not null column. Let's try to generate the response. Okay, so the API call failed, and let's find out the reason. Okay, so the call timed out. We can try again. This has happened before many times. Okay, so this time it ran successfully, and let's create a new cell and check out the response. The API tried to create the insert script, but it couldn't create all the 10 rows. So it seems like a token issue. I'm going to increase the length of the token. Currently I have max token as 150. Let's increase this to 1000 and see if it's able to give me the entire, all the insert statement for all the 10 record. Let's call it again. Okay, so it ran fine. Alright, so now I can see all the 10 record in the insert script. Let's save this in the final query variable, and then we will call the database and we'll use the same old syntax, except for I have to change the variable name. And okay, so now when I run this, it should be able to insert all these record into the customer order table. Okay, so it failed. It failed because I did not run this part. Let's run this. So now I have the correct query in the final query variable. Now it should run. Okay, so it ran fast. and let's check out the data in the database. I'm going to refresh it. Okay, so now I can see all those 10 record. The response from the API is pretty accurate. I don't have to change anything in the query. It just runs straightforward in the database. So far it's good. Let's create another type of query where we are going to use the where clause or group by clause. So I'm going to retrieve only those record where the order status is pending. I'm going to keep the column list with my prompt. I'll just change the statement and I'm going to use the correct value so that my where clause will be exact match. Okay, so this has given me the query. Select customer ID, name, email, order ID, and all the columns with the correct where clause. I'm going to use this and run it in the database directly. Okay. Alright, so it's working fine. I just got the list of 2 records where the order status is pending. Okay, moving on, let's try to create a query with the group by clause. I'll create a new cell and change the prompt. Let's see what we can do. I'll try to get the record count for individual order status. Yep, that seems like a good query. Let's change the prompt. Write a SQL query to get number of records grouped by order status column. The table has, so I'm just changing the prompt a little bit and see if this works or not. Trying to introduce multiple statement divided by the period. The table has following columns. Okay, let's run it. Ran successfully. Create a new cell and let's see the response. All right. So this is good. All right, let's run this in the database and see if it is running or not. Okay. Okay, so I did not mention the table name anywhere in the prompt. Let's mention the table name. The customer order table has following columns. Now let's run it and see if it gives me the right query. All right, I think this looks good. Let's try it. This is working nice. So it has given me the number of record for each of the distinct order status. Okay, so this was also successful. Let's try to make this more complicated. And now we will introduce the joins, like inner join or left join. So in order to do that, I'm going to create a table and then I'll ask the prompt to join with that table. I already have the syntax for that other table. So let's create the table and the table name is orders. In this table, I have 3 columns: order ID, item name, item price. And order ID is going to be the a joining column between the customer order table and the orders table. So it's acting as a foreign key between those two tables. Okay, and let's insert few record. Let's check. Okay, so I have introduced almost 9 record in this table, and intentionally I have left the 10th record, so that when I try the left outer join, it should get everything from the customer order table and only the matching record from the orders table. Let's go back to the script and we'll write a new prompt for the join. Write a SQL query to get the order details from the orders table for every customer in customer order table. I have already given the table structure for customer order table. I will also give the table structure for orders table. The queries are becoming so long to fit into one line, so I'm going to use the multi-liner comment. And split the query to multiple lines. So let's read the prompt again. Write a SQL query to get the order details from the orders table for every customer in customer order table. And then I have given the table structure for both the table. Let's run. Looks like it's going to time out. Yes. Let's run it again. Okay, so it ran successfully. Let's create a new cell. And let's see what the query is. So it's getting me all the order details. The query seems to be correct, but I also want to get the customer details. So I'm going to change the query, write a SQL query to get the order details. Let's throw in another sentence. Also get the customer details. Okay, so this seems to be better. It's getting me the customer details and then the order details. Let's run this query in the database and see if it is running or not. It ran fine, basically getting all the columns from both the table, and it's only giving us the matching rows depending on the order ID. Let's check the same query, but let's limit the number of columns. Maybe we can just specify the column names, the one which we want. So in the prompt, I'll change it to get the following columns. Name, email, and then item name and item price. Okay, let's check out the query. Okay, so it has gotten me only 4 columns, which is good. That's what we are asking for. Okay, so now this seems better. Okay, so the inner join is working fine. Let's also check out the left outer join. write a SQL query to get the order details from the order table for every customer in the customer order table. Also include the customers whose orders are not present into orders table. I will include the order ID, customer ID, that way I will know that I have all the 10 customer from the left side. It will be easy to recognize the record if I have the ID. So let's include the customer ID as well. Let's run it. Okay. So now the query has changed to left join, which is what we expected. And let's run this. Nice. So there are basically two records where we don't have the corresponding order ID in the order table. Let's also include the order ID. Okay, so I don't have any order record with the order ID equal to 5 and 10. Okay, so it's giving me correct result. So far it's been working really good. Now let's try one of the complicated problem which usually get asked in the interviews. Let me write down the question here. Okay, so this question I have taken it from one of the website and I'm pasting the prompt here. So in this query what I'm asking is, get me the employees who received raises year after year for 3 years. Okay, let's go to the database and set up the table and insert the record in order to make this query run. So I have the script here. I'm creating a new table which is called employee, and then I'm inserting bunch of record in the employee table, and then this is the actual query which I'm supposed to get from the API. Okay, let's run these two query and let's check out the data. Okay, let's order by employee ID year. So we will sort this. Okay, let's try to generate the query using the API. I will change this. Write a SQL query to return the employees who have received at least 3 year over year raises from employee table. And I'm asking the window function to solve it. Let's remove this and see what it does. We'll ask the window function later if it's not able to generate the query. Okay, this is the query, and let's change the variable name and run this. Looks like it's going to timeout. Let's run this again. So it has given some response. Let's check out the response. Okay, so it has given me a query where it's checking the minimum number of record for certain employee has to be greater than or equal to 3, and max salary should be greater than the minimum salary. Let's check if this query works or not. Okay, so this query is working but not 100% correctly because it's getting me two employee 1 and 2. 1 is the correct answer, 2 is not the correct answer because the employee 2 is not getting any hike in the year of 2020. So ideally it should not get me this employee ID equal to 2. Okay, so it's not giving me the correct query. Maybe I'm not able to give the correct prompt. Let's change the prompt to something else. Salary raise for 2 years in a row. Let's see. Okay, let's check out the new query. Okay, so this query is also not working. I'll try one more time and then probably I'll drop it if it's not able to give me the correct query. Use the window function. Okay, so this query, let's try this one. Okay, so this query is working fine and it's giving me correct result because it's checking the salary. Basically, it's picking up the previous record and then previous to previous record and then comparing between those three records. So basically, the salary should be greater than the previous salary and the previous salary should be greater than the previous to previous salary. Yeah, so I'm kind of impressed with the SQL query generator. It's even working for the complicated queries. Nice. Okay, I think this is where I will stop, experimenting with the SQL queries, but I want to end the video with some of my observation. So in order to get the result, the prompt has to be very clear and precise. And for me, it's more like learning another language to generate the SQL language. In this case, it is the correct usage of English. It would take some time to fine tune the prompt to generate the correct SQL query that can run directly into the database. Another thing I want to say is the person who is writing the prompt has to have the understanding of databases, tables, data type, or queries. In my opinion, it will be too hard for a person who does not understand the database to write the prompt. And as the problem gets complicated, it will be harder to explain in the prompt. But that's the improvement needed from my side. This feature is definitely useful for senior manager or leadership role who are not very proficient in writing scripts, but they have better data knowledge. They can query a lot of stuff if they have the data glossary of all the tables in the schemas and databases. That's it for today. Thank you for watching my video. Please like and subscribe and let me know if you have any questions.